this is a 3D printer. It's similar to an ordinary printer, except that instead of depositing tiny drops of ink on paper, it deposits tiny threads of melted plastic on a platform, building up layer upon layer to produce a solid three-dimensional object. Though still in its early stages, this technology is being called revolutionary by some and capable of changing society in major ways. We'll examine this technology and what it could lead to on this episode of Future Talk. Hello, I'm Martin Wasserman, your host, and I'd now like to introduce my guests, Clay Lambert and Blaine Demlow. Clay Lambert is General Manager of the Menlo Park TechShop, a do-it-yourself workshop that offers access to a wide range of tools, including 3D printers. Blaine Demlow is General Manager of the San Francisco TechShop and is also on the advisory board of a company called Type A Machines, which operates out of the TechShop. Type A Machines designs and builds 3D printers, and Blaine's role is to develop new uses for the machines. Clay, we have a 3D printer right here. I understand that we're not going to be able to give an actual live demonstration tonight, but what are some of the features on this? Could you explain a little bit how this device works?
Sure. This is a desktop 3D printer. So this is a fairly entry level, under $2,000, and these have come a long way in the last couple of years. These have really evolved. This machine here, it's a really nice machine. It uses stepper motors to drive an extrusion print head in the X and Y, and then it has a screw that drives in the Z axis and the up and down axis.
Now this machine says Type A Machines on it, so Blaine, this is actually the company that you're involved with.
That's correct.
Making this machine. Now this spool up here, that looks like the plastic thread that actually makes the plastic model. So, I mean, how does that basically work? I mean, you're melting the plastic and then you put it down and it solidifies instantly?
Yeah, the way it works is that it's drawn through the extrusion head and it's heated and it's turned into a molten state, and then it's deposited along a particular path that's been delineated by the digital design. And so basically it runs around and just makes a pathway, and it just deposits plastic out. That's why they call it additive manufacturing, because it's adding a layer, and it starts at the bottom and prints up, or however it is you decide to orient the piece on the bed or in your design. So that particular piece there...
This was actually printed on this machine?
Yes, it was.
Okay.
And so that's kind of a unique artistic piece. It's got all sorts of organic curves, which are very hard to achieve in other machine processes. This is one of the great advantages of 3D printing. And so that started at the bottom, and you can imagine if that just worked its way around printing out layer after layer, much like you build an ice cream cone, you know, when you do the self-serve, and it solidifies and builds itself up.
Now, what are some of the practical uses of this? It looks like it's good at creating, you know, little toys and knickknacks. Can you do real important stuff with it?
Yeah, this has been the latest breakthrough in that in the early days we used to joke about this, that so much of the printing that came out produced items that were, you know, little Star Wars figures or things you could buy at a dollar store, and they were novel because they helped us with design. But right now we're just on the verge of being able to do actual practical things. I brought a couple things on the table here that kind of demonstrate that. Like these two items are a good example. These are both models of industrial pieces.
You want to hold it up to the camera so we can get a good picture of it?
Yeah, thank you. These are both models of industrial pieces, and this particular one looks like it's it's an impeller vane for a pump. And the challenge here is that if you brought this to me in a machine shop and asked me to make a copy of this for a prototype, this is about a $7,000 to $8,000 process for me to carve this out of aluminum, to draw the file and to machine it, and it's very tricky. In this orientation here, this is about a $9 part that took about 9 hours to print, but it does give us the actual dimensions within a certain degree of accuracy, but it allows us to handle the piece. We can use this now in a mock-up assembly to see what comes next. So what this allows us to do is to do a very cheap early stage prototype, where before this stage of a prototype was impossible to produce at that price. So now what we're going to find is that a whole bunch of people, industries and inventors and entrepreneurs, are going to be able to make mechanical mock-ups of pieces that they're actually going to produce. And so we're going to move away from just whimsical features to actual pieces that represent things in machines that are going to be produced.
Now I see something interesting here. This is a chain, a series of links. Now how do you print something like this and make sure that the links can move with respect to each other and are not all stuck together.
Yeah, that's a unique, the way it's nested. And so basically when you do a drawing for the basic link and you set that up so that they're all laying next to each other and they're overlapped, and then the printer, because it's printing from the bottom up, it's going to go ahead and be able to print 2 links at a time or 3 links at a time. And when it gets to the point where they all have to be joined, since it's working in this plane, it can travel over the top and build those up until they finally connect. And so there's all sorts of interesting objects that you can print within objects that have been very popular to discuss, like this is one of them. Or there's a very popular one on YouTube where you could actually make a crescent wrench or an adjustable wrench with the thumb screw and everything, and it actually works as soon as you take it out. Or we've printed nuts on bolts before. You can take them out of the printer and they're just already screwed on and they work perfectly.
Okay, very good. And we're going to continue this conversation, but first, we recently went to the Menlo Park TechShop to take a look at some of the 3D printers there. Let's go ahead and roll that tape. We recently went to the Menlo Park TechShop, which is a large do-it-yourself workshop where members are always building interesting and unusual gadgets. The tech shop not only has a wide variety of woodworking and metalworking tools, but it also has a lot of electronic equipment, including 3D printers. 3D printers are somewhat similar to ordinary printers, except that instead of depositing tiny drops of ink on paper, they deposit tiny strands of melted plastic on a platform, building up layer upon layer to create solid three-dimensional objects. Chris Sasick, who teaches a course in 3D printing, gave us a demonstration. Chris, I understand you're going to give us a demonstration on this 3D printer here. Could you give me an idea of how it actually works?
Well, this is the MakerBot Replicator 2 3D printer. It is a printer that uses a PLA filament. This filament is PLA. It's made from corn, so it's actually biodegradable and food safe. And
it's plastic, right?
Yeah, it's a plastic. And it goes into this extruder where it gets very hot. It's going to get up to 230 degrees centigrade, and then it will come out through a 0.4 millimeter nozzle and run in a path that's designed by the computer, and we'll build our object up one layer at a time.
And what are you going to print for us today?
I was thinking to print a spiral staircase for you today.
Well, let's get started on this print. Can we?
Sure deal. Let's go.
Okay, let's do it.
All right, first thing I have to do is feed the printer. So I'm going to go and load it.
What are you loading?
I'm going to load the filament into the printer.
Okay.
So now that it's ready, load this in.
And that's all you do. You just stick it in that little hole and it probably clamps somehow.
So it was a spring-loaded plunger here that presses the material against a little drive wheel. The drive wheel has little kind of teeth on it. It grabs the filament and pulls it in. It gets hot in the extruder, like I said, 230 degrees centigrade, and then it starts to come out. And you can see it's already feeding out, so we're good. We can stop this now.
That's not part of the object yet, is it? No, that's just...
No, this is just letting us know that the machine is loaded and ready to go.
Okay, so we're looking at a spiral staircase, and now it's going to be cut into horizontal planes, and each plane will be sent separately?
Well, essentially, so we have our 3D model, and what it does is it slices it according to the resolution that we asked for. So I asked it to print it at 200 microns of resolution. So it's going to slice every 200 microns will be a new slice. So right now you can see the bed rising. All the information has been sent to the printer. The printer now will heat to its correct temperature, and then it will go to its home position and it will start printing.
3D printers are still very slow, although they're continually improving. Chris's 6-inch spiral staircase took about 3 hours to print. In addition to this desktop printer, the tech shop also has a larger 3D printer, a floor model called the ProJet, which unfortunately wasn't working the day we were there. Justin Leathers is in charge of the ProJet printer. Justin, what's your involvement with 3D printing at the tech shop?
I run the ProJet HD 3000 high-resolution printer for the company.
And what are the capabilities of that?
You have the ability to print larger prints or even smaller prints at higher resolution than you do on something, say, the MakerBot. But with that, it's much more expensive and it's much longer, so it takes more time to actually produce a part.
What sort of things do people actually use it for?
They print everything from test pieces for prototyping to small production runs. I've printed, one of our members uses it to print 96 tooth gears that are about less than a centimeter in diameter. So it has that kind of resolution capability.
Does it take any particular training to use a 3D printer? So here, for example, if someone wants to print on the machine, do you do it for them or do they operate the machine themselves?
For the ProJet, we print it for them just because it's a little too complex, and usually we can print more than one person's print at a time. So that way our build time cost goes down instead of increasing per print. Because it could take 15 hours to print a part and 10 hours to print another part. We can put them both on the same bed, and that way it takes 15 hours to print both parts.
Before you can do a 3D print, you have to define the object you're printing. One way to do that is by using a 3D graphic modeling program, such as the Inventor Software from Autodesk. Using the Inventor Software, you can quickly define objects of almost any size, shape, and complexity, and even add scaffolding under the overhanging parts so they don't collapse during the 3D printing process. And if you want to make a copy of a physical object that already exists, you can use a 3D scanner, which creates a precise 3D image of the object and stores the image on the computer. Chris Sasick demonstrates.
Well, we've got our NextEngine 3D scanner set up, and what we're going to do is we've got an object here. It's a little pipe section, and we're going to 3D scan this pipe, and we'd be able to then 3D print it and have a replica of that model. We could even take it into some software and manipulate it a little bit if we wanted to change the design, so to speak.
Okay, so let's see how that works. You just turn on the scanner and it scans?
Essentially, yeah. I've already set it up to scan, and when I hit the start button, it should start to scan. What's going to happen is it has some lasers, and the lasers will sweep across the object to get measurements, and then it has a couple of cameras, and the cameras will take pictures of the object, and it will rotate around. This scanner can scan up to 40,000 dots per inch, which is very high resolution. And then basically what it does is it takes all the images that we scan and it brings them here, interlaces them together, and then we have our model.
Finally, we discussed some of the TechShop's more unusual printed objects, including spheres within spheres. So we've seen the 3D printer in action, and now on this table we have a few objects that were printed by a 3D printer. Now one thing here that really interests me is this right here, because this is a ball with a sort of latticework honeycomb design, but it's, let's see if we can get a good shot of that. It's a series of nested balls. Inside this ball there's another one, and then a smaller one and a smaller one. I can't even tell how many are in here. It looks like it's at least 5 or 6. And this was all printed in a single print job, is that right?
Yes, this was printed on our higher resolution 3D printer, the HD ProJet 3000 from 3D Systems. And what they do with that printer is it uses a laser to actually cure the material in place. And so it's just built up layer by layer. So that's why you don't have any interference from one layer to the next, because they're just built up one layer at a time. And then it uses a wax between the acrylic layers so it can support the balls within each other and they don't actually touch. After we're done printing, we take this out, we dunk it in a little bath, wash all of the wax away, and then we're left with our model. Right now it's still a hobbyist thing. It's still few and far between, I think, for people who actually have them at home. And I also think there's a lot of people that have them that don't know what to do with them. But there's a lot of people out there just making cool things. And I teach the 3D printing classes here at TechShop. And the number one answer I get from people when I ask them, why are you here? And they say, because it's cool. And they just want to understand what it's about.
And that was our video from the Menlo Park TechShop. Clay, what has to be improved about 3D printers in order for them to become popular in the mass marketplace?
Well, there's going to be, excuse me, there's going to be a variety of things that different people will tell you. But I'll tell you the reliability of the extrude head mechanism. There's a lot of folks that are working on that, and they've made a lot of strides. These guys are actually really good at it.
You mean like preventing clogs and things
that's
like
right,
that?
yeah. Preventing clogs, switching between different materials. I mean, this is PLA here. This, as you can see, this bed is not heated. And PLA, you don't have to have a heated bed. It's very comfortable as far as shrinkage of the material during the printing process.
What about the time it takes to print? It seems like it takes a really long time to print even a small object.
Speed is an issue, yeah.
What would it take to speed that up?
You know, I don't know if in the near future we're going to be able to speed the printing process, but one of the things that might really leverage the whole industry forward is that if the reliability of the print goes up and you can use the printer during off times. So if you can turn it on when you leave the shop or leave your facility and come back in the morning, and you can take advantage of all that downtime for print, in a way it's almost like it now takes none of your useful time. And so one of the big things to leverage now is to have the printer run unattended for 10 to 12 hours at a time and still be successful in its printing. That's probably the first thing that'll happen to make the prints come out quicker to us. You know, the second thing will be involved in the materials that we actually print with. How fast can they be extruded and cured and maintain their dimension?
Now, right now, many people think that it's only, for hobbyists and things like that, but there are also some very serious users as well. In fact, we have a video. One of our correspondents recently went to Oak Ridge National Laboratory in Tennessee, where they're very big into 3D printers, and we're going to take a look at that video. So let's go ahead and roll that tape. Future Talk staff member Greg Weinstein recently visited the Oak Ridge National Laboratories manufacturing demonstration facility in Oak Ridge, Tennessee. The researchers there, led by Dr. Chad Duty, are developing high-end 3D printers. This large printer, which prints in plastic, cost $500,000. This $1 million machine can actually print titanium parts. Here are some objects made with the printer, including titanium robotic hand parts. This bouncing ball is also made of titanium. Chad Duty discusses his views on the future of 3D printing.
You're going to see it being more and more widely used in the consumer markets, to where your average person is going to see it on a daily, weekly, monthly basis. And it's going to probably start off with niche applications, cell phone covers, little fittings, devices, replacement parts, things like that. But I think it'll go mainstream very quickly. I think what you're going to see is components will have added functionality that in some cases will be apparent to the average consumer. In some cases it will be the hidden functionality that just makes something work better and you don't really know why.
And that was our video from the Oak Ridge National Laboratory. Now, what is the future of 3D printing regarding traditional manufacturing? Do you think that this could someday replace traditional assembly lines?
There are a variety of areas where 3D printing will ultimately, I believe, displace some mechanisms, some methods that are used now. I think that it's quite a ways down the road. It goes back to what Blaine said as far as speed and reliability. I think that they're going to be in the use for development for quite a while.
So prototyping parts.
Yeah.
You can make a model of what something will look like. But as far as mass production, comparing it to something like injection molding, for example, which is a very inexpensive way of mass producing things.
Right. Or I've heard talk that at some point, maybe when you go to get a replacement part for an appliance, for example, that they won't actually ship in a part, they'll just print it for you on site. And so that's a great goal, but we're years away from being able to print that in a reliable way. For that to actually happen. But that is on the horizon. And so as material science is able to kind of really wrap its head around what can be done with 3D printing to make it cure into the right dimensions and that kind of stuff, there's a lot of different materials that have been introduced, and that's going to change a lot in the next 5 years, and that is going to be one of the breakthroughs that's going to probably facilitate these actually being used for production pieces. But right now, the primary goal, the best thing we can do with this is practice design work, and get drafts. And for like a company to be able to do a draft print of this for a customer, it's a huge savings to the customer and to the company to be able to approve that rather than have to make one on any other machine process. So right now, it's in the prototype and drafting that it really has a big advantage.
Now, I understand that there's another type of 3D printing technology. Instead of having a plastic thread, you have a bed of powder, and by selectively fusing pieces of it, you assemble your part right in this bed of powder. Then you just brush off the excess powder and you have your part.
Right.
Is that a very similar technology to this? I mean, is there much difference between the two?
Yeah, I believe Clay's actually operated those.
Well, there's several different methods for 3D printing, and the powder bed that you're referring to, basically what goes on is you have what is in effect an inkjet head, and it's depositing resin into the powder, and it's solidifying that portion of the powder where the resin is being placed.
So it's injecting some material. It's not like a laser that's just heating at a distance?
There's that method as well. There's a great video on YouTube that shows a guy that set this up doing melting sand using a mirror in the middle of the desert with XYZ axis functionality. So yeah, there's a lot of different ways to do it.
Well, and just on the other side of it, one of the more popular printers that's down at the Autodesk facility, which supports us with all of our software, but the most popular one they have now uses paper and glue. And so sometimes we can look to the future for all this space age material and science to solve the problem. Sometimes we can go back to tradition and realize that paper and glue produces a very inexpensive, pretty robust prototype as well, as long as it can be done accurately. And that's what the CNC technology does for us in 3D printing. So I think we're going to see, the use of materials really transform the whole thing. But I wouldn't say that it always has to be something space age looking forward. We're going to find some really traditional things that are going to be remarkable.
Now, there's been a little bit of controversy here because some people say, well, you can manufacture your own guns with this, totally untraceable. You can get the plans right off the internet. Do you think there's a problem that this could be put to some undesirable uses?
Yeah, you know what? There's just about any tool we have in anybody's shop or garage can be put to undesirable purposes. And so that's really a moral problem, and that's really something that you kind of have to solve in a different way. But I think technology, what it's supposed to do is present interesting opportunities for us to be able to make changes. And some of us will choose to make those in a positive way, and some of us will choose not to. But to not make the technology available would be a mistake.
Yeah.
Is there anything that 3D printing can do that cannot be done by other means? Like, does this enable you to do things that you just can't do at all?
Yeah, well, so there are some examples here. The biggest thing that 3D printing allows us to do is make organic shapes. And so subtle curves and blends, these things are almost impossible to reproduce and machine in any other way.
Prehistoric dinosaur head.
Yeah. And so this is a figurine, but yet, so this design is drawn by someone and designed and then printed. If you had to make this in any other way, there's no way you could reproduce this. Look at in this particular piece here.
I mean, look at this. This is a blade of this is a compressor blade for a jet engine, for a turbofan, and that would be a challenge to produce on a good day.
Yeah.
With a variety of tools. The fact that there's inexpensive software out there that a 12-year-old kid can basically design a jet engine and actually produce a prototype to demonstrate that all the parts fit together. It's remarkable.
Some people say that what's missing now in 3D printing is the so-called killer app. The use of it that's so valuable that it's worth it to buy the machine just to do that one thing. Like desktop publishing was the killer app for personal computers in the 1980s. Now you're looking for new uses. That's part of your field, right? Do you see any killer apps on the horizon?
Yeah, I can just say in a general sense that we're working on some projects now that involve taking this quality grade printing and introducing certain kinds of enhancement that are going to make them structurally sound. And so then what you're going to be able to do is achieve these kind of complicated, consistent organic shapes, but also make them much stronger. And so we're right on the forefront of doing that. We're going to see that shortly.
Okay. Now, do you see big industrial uses like designing and building airplanes or things like that? Really heavy industry. Is it capable of that?
I don't think in the turnaround that heavy industry requires yet, and so, but who knows where we're going to go? There was a time when personal computers were huge and capable of doing almost everything, and then they came along to such a great degree. So 20 years from now, I would expect the ramp into this thing to be totally transformative. Where right now it's in that leading and bleeding stage, but we're certainly not ready to consider it for production now, and certainly not in an airplane part.
Now, one use might be for people who don't have access to normal parts, like let's say you're on the International Space Station and a little part breaks down that's part of the oxygen distribution system.
Yes.
Right.
You can't store all the spare parts, and you don't want to wait months for another rocket to get there from Earth. But if you have a printer and a supply of raw material, you can pretty much replicate any part. They could beam you up the design.
Yes, I think
also-
that has a real possibility.
Right.
And as the materials increase in their in their structural rigidity, we're going to find that. There's also, we've had great talks about how to use 3D printers in remote areas of the world, because it's a fairly small footprint. We could send it out to somebody, and they can maybe print irrigation parts that they can't get, or they could do small medical devices or whatever. So both in space and on Earth, I think there's some great opportunities for what 3D printing is going to bring us.
And this prints with one type of plastic, but there are also printers that have multiple heads, so you can use multiple materials at the same time
Yes,
to make
yeah.
it more complicated.
And different colors, and there's a particular printers that print out materials that are like rubber and clear crystal, and they
Right.
can integrate those, and so that's all right here, right now.
I guess it's good for artists as well, because structural strength is not that critical.
Yeah,
If you want to replicate a famous statue,
yeah. We've seen that. We had a gentleman that we worked with that 3D printed, that had a sculpture that was widely valued, but now he wanted to reproduce it in a smaller set. So he brought it to us to scan, 3D print smaller ones, and he made castings from that, and he's able to reproduce those at a smaller set of bronze castings that he offered, and he made himself a nice chunk of money from it. So there's a place where this 3D printing is going to contribute to people's ability to have a business, or the ability to make some money.
well, this is really a great topic, and I'd love to learn more about it. Unfortunately, we're just about out of time, so we are going to have to wrap the show. I've been speaking with Clay Lambert and Brian Demlow, both aficionados, I could say, of 3D printing. This is Marty Wasserman. Thank you for watching. Visit our website, www.futuretalk.net. For Future Talk, we'll see you next time.